This is Made Up of Wires. We're decompiling Castlevania Symphony of the Night. Have you ever had one of those days where you feel like nothing is going as quickly as it should and you can't seem to make any progress on what you want to do? Well, that's where I am today, and hopefully we'll get through that and get some work done. What is the Castlevania Symphony of the Night decompilation project? We are working to create a set of source code that will compile back to the original binaries, to files that match the original binaries of Castlevania Symphony of the Night for the PlayStation, PSP, and other platforms. If you want to know more about the project, you can go to soten.z.dev, where you will find progress on various files that we've been working on. You can also find a link to the GitHub repo that has all the decompiled code and tooling that has been built for this project. And you can find a link to the Discord as well. Howdy, Luigi's Evil. Nice to have you back. So last week, we had kind of an exciting addition, which was the Maria Boss Clock Room cutscene overlay being added. The way that many PlayStation games work is that you have a loader program that's pretty minimal, probably contains a main function, which is the primary entry point in most C programs. And then a stub, the SDK for that the game was built against, and then a stub that basically brings in other files at specific memory addresses and jumps to functions defined in those addresses. And Castlevania Symphony of the Night is no different from that. It has overlays for its main program, which is DRA, this game engine at the top, where we have one function remaining to decompile there. And then it will bring in several other overlays. The character overlay, weapons, stages, and then there's also bosses. And the Maria boss is a new overlay that was added just last weekend. A lot of work went into building tooling and other things like that to get the overlay in place, but the first time that other developers got to work on it was around Saturday or Sunday of last week. And as of, I believe, Saturday night, that overlay is completely finished, 100% code complete. Most of the overlays have a lot of duplicate code because they're replacing other overlays at their same offsets in memory and need to provide all the same functions when they use that same behavior. So there was a good amount of the code that was duplicated and just needed to be done. And then the last two methods or functions in that overlay were finished over the weekend. So that's super cool, the fact that a new overlay can come in and within a week we can get it done. The Maria Boss overlay is I haven't looked, I guess, at the size of it. Probably, though, it has Maria as a character. It has the clock room and other things there. It's relatively small compared to some of the other stages. Hey, Dig Down Deep. Orcam, good to have you. Why is it called this? Because it literally is overlaid. So you can imagine you have bits 0 through whatever the 32-bit maximum is. In this case, most of the time, the PlayStation is using offsets that have the first bit of that 32-bit address set, and the main program will be brought in at hex address 80000000. That's where main and other code related to it. When you see SLU underscore some disk ID, SLU, what is it called? Yeah, SLUS underscore 000.67 in the case of Symphony of the Night. That file is mapped to memory, and that mapping in memory is taking the hardware memory and putting it at a specific address. So that'll get brought in kind of at the base address of virtual memory on the PlayStation. And then the main function there is going to look at a specific offset. We can open main and see that offset. Oh no, my Stream Deck isn't working again. So in the case of Dracula, we're loading the file, and this Dracula program pointer, is that up here? Sorry, I'm forgetting the offset. I could look at the Splat config as well. We'll do that. That'll get us there the fastest. Oh, I'm wrong. So main isn't loaded at 8000, it's loaded at 8001 with 4 zeros after. And then the Dracula program is loaded at 800A000. So it's literally taking the file that's on the disk, writing it sequentially at that memory offset, and then from that point forward, until it gets overwritten, that's what's at that memory offset. So then Dracula, or that Dracula program will come in and it'll load stages at offset A0180000, and all of the offsets then for stages are there. Why is it called an overlay? I'm not sure exactly where the terminology comes from, but that's the general gist of it. So what I wanted to do today, so we have some new tooling that Zynamo created to help with creating new targets for compiling files. We're going to look at the HD version of the game, which is kind of a unique version of the game that was built and shipped on the PSP, and it actually has showed up in the iOS and Android versions as well. To the best of my knowledge, I don't know that it's actually used on the PSP because there is a PSP specific version as well. But basically it's game files that are very close to the PlayStation 1 version of the game, and built for PlayStation 1, but for some reason was shipped on the PSP discs. So we're going to look at taking one of the stages and using some of this new tooling and what that looks like to go from nothing effectively to getting an overlay built that should match. And that shouldn't take too long at the beginning here. And then I think roaming finished off weapon 17 last week. So we're down to 2 weapons. I think we'll go back to weapon 30 and look at the 2 remaining functions there and see if we can make any more progress there. I don't anticipate finishing either of those, but we should get pretty close. All right, so let's go back to a terminal. So I'm going to be working on the HD version of the game. And like I said, it's these are files that shipped with the PSP version and also have been included in other versions of the game, more modern versions of the game. On the PSP side, I don't know that they're actually used. We can look at the wiki actually and get some more info there as well. Yeah, so this is kind of the information we have here about the HD version. It's a build found in the PSP version of the game. There is a basically a parallel directory structure for the HD version of the game and the PSP version of the game. It's kind of a bizarre scenario. Not really clear what it was being used for, but we have it, and we can decompile it with the existing tooling that we have. So right now, by default, we build the US PlayStation version of the game, and that's fine. I'm going to get to build different versions of the game. You export a version variable in your environment or pass that variable to make. It's much easier when building and running make a lot, just to have the exported variable in your environment. I find how you want to do it, that's your choice. If you want to go back to the US version, you can either set version US or you can unset the version. Either way works. If I'm modifying common code headers, things like that, I'll pass the variable just as an argument to make. Otherwise, I'll export it here. So before I get into it, I want to get a clean build of this HD version. We don't have many of the overlays here, so this should go pretty quick. I'll extract and then make. I think there's only 3 files that are getting built at the moment. So last Monday, I went through setting up the project and getting things checked out and building. And through the course of that, I was also kind of tweaking things to get Python virtual environments checked in. And all that's now in the repo, and so we're using virtual environments there. So I said a bunch of stuff about changing shebangs and things like that. That no longer is relevant information. That's all been checked in and is working like it should. All right, so we have our 3 overlays. So in tools, we have a make config, and it takes an overlay name. We're gonna work on the center castle stage. And this will go through and start building a Splat config for that file. And then trying to map the symbols based on the other overlays in that version of the game. And I got an error here, so let's see what that might be. A lot of this tooling is relatively new, so I'm going to... it looks like I had maybe some other files that were conflicting. I did this a couple times this morning just to make sure that I could get a good build in. All right, so I think that's clean. Let me get rid of the C file that it created. Okay, let's try again. So I'm going to make sure that my local build is clean. It is still not. Oh, we might have to abandon this right now. We'll give it one more shot. this is not an error that I think we have to worry about. I think I have the, I have the SHA here, which is going to attempt to build that center stage overlay. But I don't have the config there yet. So now we're building fine. So we'll try again. So we're gonna use the make config script and pull in the center overlay. And what this should do is find about 99 functions in here. Yeah, and it did. And so what this script is doing is giving us our symbol table. So it's gone through and mapped a significant number of the function symbols for us, so that we don't have to do 99 of them. It's created a new Splat config, which has a basic set of sub-segments in it. So Splat is the tool that's going to be extracting code and assets from each of the overlays. And we need to tell Splat basically what offsets into that file each of those things are at. So when a overlay file gets created, it has different segments in it. And these are laid out very similar to an ELF file if you're used to Linux or some other binary program where there's a data section. RO data is read-only data, so that could be static strings or jump tables for switches. C code, which is stored in a text segment. And then BSS and SBSS, which are uninitialized variables. So that's created, and it also created a C file, which is going to include all the assembly that was pulled out. Many or most of these functions are things, the ones with symbol names almost universally are going to be things that are decompiled already. The ones with a func HD prefix, those either haven't been matched to an existing function, and these are functions just in this overlay, just in this game version. So it's likely that these have been decompiled already, or something very similar has been decompiled. So now we can go through, go into the make file, add entries for these. And I'll just put the minimal set in. And then I want to go in as well into our SHA file. And add an entry there. And that the SHA that we're checking against is the same as the one that's in Splat config. But this lets us use the SHA utility. Oh, I have it in there already. Great. Oh, the make config did it for us. So now we need to extract again and build. And now we're building the new center stage overlay. And that's matching. We have a ton of everything in that file that was created is the right file is include ASM, and so we need to go through and start mapping these to existing functions, but we have that in place. So one of the things that I wanted to show as well, like how would we go through and start either mapping this to existing code or bringing in existing code. And that's probably beyond the scope of what I'm going to do in the live stream today. But I'll show a little preview of what it is. We won't get a match quite yet, and there's a good reason for that. Will you be keeping two versions of this overlay or if-defing the differences? Yes, they will be if-defed as much as possible. And let's look at this entity room foreground. So if, sorry, let's get the right Splat config. So I want to look at the US version of the center overlay, and I'll compare it with what we have now for this HD version. One of the first things that I noticed when I was looking at this, so we have very few subsegments configured here, quite a bit more in center, and this is fully decompiled for the PlayStation US version. That this entity room foreground function, which is the first function, so these are in order of how they exist when the game is compiled. That's going to be defined in this entity room foreground C file. We can open this up and look at it. But when we look at the ordering of the US version versus the HD version, this is one of the last functions in this overlay, and it's the first function in our HD overlay. So we can't just use that config. Not only that, but it actually ends up being a different version of that function. And so we'll look at it and see what that looks like. So if I wanted to bring this in, I have to look at a couple things. First, there's a data segment of this file, as well as the text or code section of this file. And so we need to understand basically where both of those things are going to go. And so the other thing is how much space is this taking up? And this is why I think that they're different implementations. You can determine how much space this is taken up in the file by looking at these offsets here and subtracting. This ends up being, I think, 64 bytes or 60 bytes. Yeah, 64 bytes. Let me do that math. Oh, I'm sorry. It's EC bytes. Of course. EC is 236 bytes. However, if we open up the ASM for this HD version, so this is going to be stage, center, non-matching. So we're looking for entity room foreground. We can look at the last instruction here. +4 is going to be the offset for the next function down. And then we can subtract the initial offset and that gives us EO. So the original, or the US version, is EC in size, and this one is EO in size, so C is 12. So the US version is 12 bytes bigger than this version. So there is a difference between the two, and so we need to figure out what that is. So I can bring that in and use the existing version, but we need to do a little bit of cleanup first. So the we have two variables here. Let's open the this is E room foreground. Sorry, the wrapping might be a pain. So in our assembly version, we have these symbols that didn't get names and they're anything D underscore and then some big hex value. That's going to be an unnamed symbol. We have 2 of them there. That's going to correspond to this E room foreground init and E init generic 2. One of those is external to this original file, and the other one is defined as a static variable in this file. Right now we don't want to take those specifically, but what we can do is use these addresses to add additional symbols and regenerate this extracted assembly with the correct symbols in place. And so while we might not be able to reuse this code directly, it does allow us to start mapping symbols and getting a little closer and closer and closer. Inline deferred, which flips the function order for I'm not sure. There's a couple different oddities that I can't speak authoritatively to yet. I know in the main overlay where the main function is and the way that that is compiled, the way that the PlayStation SDK reorders functions is based on values in a hash table, and the folks that worked on the Frogger decompilation project went through great pains to document this, and so you get as the compiler is coming through and deciding how it's going to order things in the final binary, it's putting all the function names into a hash table as the key, and then those functions are written out in the order of that hash table. And if you know anything about hash tables, the keys are, the keys, you want as much entropy as possible. But fortunately, because this is GCC, we can look at what was the hashing function they were using. And once you know the hashing function, you can basically manipulate it to rename functions in a way that gives you the correct order. And that's kind of the tooling that they built to get functions in the right order. So far, what we've been doing is making sure that splits, is that functions or variables? That might be variables that I'm sorry, it's variables, globals. We've been making splits such that those symbols end up in the right place, but it's a very manual process. And one thing you don't have when you're decompiling is what the original names of things were, which is why the Frogger project built that tooling. And basically they append semi-random variables or semi-random extensions to each of the names to get them to hash to the correct order. Okay, so let's look at this a little more. What I want to do, we have these variable names, and I happen to know, because I've looked at this just a bit, that these are being loaded in order. We have this E room foreground and global E entity generic 2. These correspond with these 2 variables here that we don't have names for yet, so we can add that mapping. I'm going to open this in a new tab. And we just put that in the symbol mapping table. So I'm going to grab these names. And we just set them equal to the address that that we found in the assembly. going to back out of most of this, and I'm going to stage all of these files that I've changed so far. Because when I clean, right now the make file will obliterate all these, and I don't want them obliterated. I want to get back to these. All right, so now I'm going to make clean, extract again, and we'll make. If you're just tuning in, we are looking at some new tooling for the Castlevania Symphony of the Night decompilation project, which allows us to more quickly add overlays so that we can decompile more and faster. All right, so we're compiling again, and what I want to see and what I expect to have happened is the symbols in that extracted assembly for entity room foreground should now be named the values that we named them, and they are. So instead of the values that we had before, we now have that were based on the memory offsets. We have nice human readable names. I'm going to take this file and we'll run this through decomp.me, and we'll see what changes need to be made from the original that are giving us that 12-byte difference. So off screen, I'm just copying this into a buffer. I use tmux to do tab management in my terminal, and tmux makes it difficult to copy things that are more than one page with the workflow that I have. That's why I go off screen and copy it. So I'm going to start a new PlayStation decompile. I'm going to check my primitive in context and just make sure I'm not using the PSP version. I'm not, so that should be fine. And create a new scratch here. And then because we have the original already, we know these types. Sorry, we have the US version, US PlayStation version already. We know these types and should be able to get a clean compile and see what the differences are. So kind of in the background here, I'm going to be loading that and just pulling in these types. So animate entity is, I believe, a void. eRoom is a object init array. And then we had one more, which was object init. Sorry, the global eGeneric 2. That one looks like we have a definition for already. So I'm going to rename this and copy this into the context and get a fresh decompile. Okay, it thinks that we don't have. Oh, I have an error in my context. That's why. Do we have object init? I don't have this structure, so I need to go find this structure. This is in the include directory in game.h. So that gave us a clean decompile, and will this give us... there still is a type that is unknown. Temp S1. For some reason it wasn't able to get these. So offset 8 is draw flags. And offset A is draw mode. Alright, so the decompiler actually gave us a perfect match, which is nice. So now I'm going to pull in the original, and we can kind of see what the difference is between the two. So the version that we have checked in looks like this, and this gives us a not perfect match. And where is the difference? The difference is down here around line 15. So let's kind of flip back and forth and see if we can see what the difference is. So in our decompiled version, we can get rid of this temp v2 that will, or sorry, temp v0 that will give us something slightly cleaner. I'm going to jump over here and set the no built-in flag to get rid of those. Temp v0 undeclared. Where did I select that? All right, so that gets us back to a matching function. And let's look at what this is here. So the first thing I see that's obvious is we're checking params against equality with 1 here, versus the existing version for the US is looking for greater than 4. In that conditional, then, our matching version, we're setting the X and Y rotation, and I wonder if we can reorder these to... Nope. I was hoping that, this would be written rotate X equals rotate Y. Get the X and Y correct. That makes me feel a little better. And we can, to get it as close to the other one as possible, we can change this temp S1 variable to object init. I'll have to look at copy mode. Thanks, Tux Can Play and Orcam. So I do use copy mode if I'm using tmux on the same system that I'm working on. I don't have integration, and maybe this exists and I haven't found it. So I'm running my just terminal.app on a Mac, SSH'd into Linux box, and so I can copy and paste within the context of that terminal session without issue. It's getting that copy buffer back to the Mac. And I'm sure there's some something I could forward over an SSH port, and that would link back to my Mac copy buffer. But I just do it off screen. All right, so that should look pretty close to the original. It looks like there's some ordering. Let's put both up on the screen at the same time. And we can make sure that we, so Z priority, unknown 5A palette, draw flags, draw mode, so that is all identical. The way that step is being checked is different, and we're doing this all in one line. So I think that the only difference, and I'll do this one more time. I think that the only difference is that condition at the bottom. Oh, the original, instead of taking self, was taking was calling the parameter entity. So we can do the same to make the flipping back and forth a little easier to follow. Yeah. Okay, so yeah, the only difference between these two that I see is this condition at the bottom. And the condition at the bottom is quite a bit different. So roaming S earlier, what do we do in that situation? Yeah, we're gonna put an if-def in. And one thing that I think would be nice to have, I ran into, we'll get back to the Entity Maria cutscene from Thursday, because there was something interesting there that is relevant to this, actually, that we can talk about. So we don't know if this is being pulled in. I don't happen to know anyway. Actually, it should be being pulled in already to the PSP version. So I'm going to if-def this specifically for HD, and everybody else can get the original version, or that other version. So now what would be nice to be able to do is pull this in and replace that include ASM. So let's see if we can do that. This may or may not succeed. I didn't spend any time looking at the differences prior to the stream, so I don't know if this is going to work out well or not, but this is how I would go about it if I were going to do this in real life. So I'm going to open the Splat config. And from looking at the ASM earlier, we know that the initial offset for this function was D5E8. And we can look at that include ASM. Get rid of that. We can look at include ASM, or the file that was generated, and get our next function, which is this entity unknown ID 12. Find the assembly for that. So this is get its starting point, which is D6C8. And we're going to create a new segment in Splat, starting at D6C8. It's still going to point to that HDC file, but in we're going to say D5E8. We want that to get its code from eroom FG, which was this C file that was being updated before. If any of that doesn't make sense, feel free to chat, comment if I'm going too fast, or if you want any other info along the way, let me know, and I'll try to address it. So one of the things that we have in this file that I'm going to ignore for the moment is we have a bunch of static data at the top. And we have one reference to an external variable here. I'm not too concerned about that. When we compile this eroom foreground function, And that's what I'm going to get to. So one of the things Splat does for you is generates a linker script. And the point of writing all these segments and what their offsets are is effectively we're telling Splat how to write that linker script for us. So when we use a dot in front of a name, we're telling Splat, go find in the compilation directory, which we have way at the top here, which is build HD. In build HD, there's going to be a stsen.o file that gets generated. Sorry, it'll be stsen.elf. Not important. There will be a, in that build HD directory, under source stsen, there will be a eroomfg.o file. And that is just GCC compiling an object file with all of the different segments that come along with that object file. Splat is going to write a linker script for LD to come through, and when it's creating the final elf file for this overlay, it'll go through each of these, and for eroomfg, it'll take the text segment, which is where our code is compiled to, and stick the text section or text segment from eroomfg.o. It will write it to D5E8 in the final final file that it compiles, if that makes sense. So we have data that's going to be compiled into our .o. We don't have any RO data, and we don't have any BSS or uninitialized data in this file. So that should be fine. And what I'm hoping is going to happen, and we'll see if it does happen or not, the Splat linker script should just ignore the data segment of the eroomfg file and just pull in our text segment. And let's see if that works. So I've modified Splat, so I have to run a make extract again. Actually, there's one more thing that I need to do so that otherwise we certainly will fail. In this hd.c, I need to get rid of my include ASM here, otherwise now we'll have two versions of that function, and we'll be offset by one of them, and everything will fail at that point. I shouldn't have to extract again after that, though. So let's build and see if it works. Fingers crossed. I don't know if it is going to work or not. It failed. Okay, that's fine. And let's see if we can tell what our failure was. Okay, it's something bigger than just an offset issue. Let's see. I need my file and the one we just built, as well as the original. So we do have some address offset differences at the beginning. So the way that the overlays are set up, we at the start of a stage overlay, we have a bunch of structures that basically define function pointers to different areas, and it looks like something I did along the way mucked with those offsets. And so we have 1, 2, 3, 4, 5 functions that are now at the wrong offsets. Once you have one thing that is offset incorrectly, it's very common that other things are going to start being offset incorrectly as well. I could continue on and try to debug this, but what I wanted to show was creating new overlays now for different versions of the game is relatively straightforward. We can use this actually for the PlayStation and PSP versions of the game as well. And it is kind of neat to be able to find small differences between the two code bases that eventually we'll have to if-def around. That's all I'm going to do for that new tooling today. Let's go back and work on some weapons. I'm going to save this and see if I still have... It's been a while since I've looked at any of the weapons, about a week, so we can see where we were. And I'm going to open this weapon up and see which one it is, because I have forgotten. I always forget that there's a little lag between the stream and chat. I think if more people would have crossed their fingers, it would have worked out better. So this was Sword of Dawn. Is Sword of Dawn the one I have up? No. So this is what Roaming was working on last week, which is the pentagram and all these awesome triangles. Super fun. Let me find, where is my wiki? Oh, this is a nice one. All right, so we're going to be working on Sword of Dawn, and I haven't gone through and looked to see whether or not anybody's done any additional research on what the two functions after Entity Weapon Attack are. Most of the weapons have these implemented. So Entity Weapon Attack is the primary weapon function for each individual weapon. And then there's a second function as part of the interface to weapons, and we just call that function pointer 80170004, and then there's a 0008 as well, and those are the two functions remaining for the weapon 0 object. And let's see, I kind of have to refresh my memory as to where we were and what we were looking at. I also don't remember if there was a PSP version of this, because that probably is the way to go at the moment. I don't see that I have a PSP version, which is a bummer. All right, let's go through and see what we have. When I'm decompiling, I kind of reiterate this each stream. Initially, I'm going to ignore stack pointer differences, register differences, and some immediate differences. In this case, this immediate difference is a branching offset, and there's nothing that I can do to manipulate that value directly. I have to there's 40 bytes difference between the two. I need to figure out why that 40 bytes is missing, and so we see some of it here. But actually, these instructions are each 4 bytes. These two are just replaced kind of out of order here. So we need to figure out what's causing that difference, and it's not really something to address directly. This looks almost like it's pretty early on. So I'm just going to kind of go top to bottom and see where we are along the way. So the first difference is here. There's a load immediate of 4 that's happening out of order. And there's actually a load immediate here as well. So it looks to me like possibly these are being done in this order, and that matches. So I was looking at these instructions here. Where are my loads happening? The decompiler decided that it was going to try to set this variable before checking the random. We might be able to rewrite that as a ternary. Yep, and that compiles to the same thing. Ternary fans in chat? Throw your love out. I worked at one of the Fangs for a while, and one of the best things that I pulled away from that experience is writing ternaries on 3 lines like this. That syntax to me is beautiful. Doesn't matter in this case because we have just immediates that we're assigning to, but actually we don't even need this. We can just assign directly to weapon 90. Hey Biz Murphy, good to have you in the chat. That's a good question. Do I prefer the equals or a not? I prefer whatever is going to compile on the PSP. So we'd have to go we'd have to go through and see what compiles there. So we use Clang format, and I think it's just the default. So Clang format is, to me, one of the most frustrating tools because it is so good and so inflexible. We use Clang format though. It goes through and we'll rewrite the code as much as possible. So on the project itself, our concerns are more about naming, and we just had a discussion this morning in Discord. I lurked, I didn't participate really, but how if-defs should be written. So in the case that was there before for that entity room foreground, both the condition as well as what was happening in that block differed, and so to me that's pretty obvious. You just you if-def one side or the other, and the whole condition and block get rewritten. In the case that was being discussed in Discord, though, was multiple conditions were happening in an if statement, and on one version of the game, one of those conditions was different. So where do you if-def? Do you break apart the condition and kind of split the if-def there? Do you take the whole control statement and rewrite that on either side of the if-def. So those are still open questions, and I don't think there's an official style guide for things like that. A lot of times code reviews will kind of pull those things out, and people will talk about them there. Okay, so on 102, there's a load immediate, and these are happening out of order. And why is that? I don't know if it's obvious at the moment. Oh, we do have a word being pulled in on... Oh, that's this line, sorry. So our var v0 underscore 2 is a 32-bit value. It's being stored into a field that's a 16-bit value, so we need to go and fix this type. I'm going to try to just cast this whole thing and see if we can get away with not having a variable at all. No. It's somewhat odd. And I'm trying to see where this 4 is coming. Oh, that's the prime GT4. It's odd that this store is happening out of order. I will go back and take that out as a variable again. And we'll try making this a 16-bit value. Oh, it is a 16-bit value. So why are we getting a store word? Store word is 32-bit, storing a 32-bit value. Odd. All right, I'm gonna skip that. I don't see anything obvious. It may be something that PSP could help us with. All right, so now we're missing a add of immediate value 38. And moving that into a register. So we have a mask up here on line 116. So it looks like these V, usually UV, are done in that order, but for some reason these are happening out of order. Changing those does not change the order. All these RGB values are one big assignment. I don't know if reordering these is going to make any difference. It is possible, though, that these are happening after the RGB is set. No, it's not helping either. That's probably why I left this function a while ago. Yeah, RBG. So let's look at these. 465. Unfortunately, with the way the optimizer is set up, it can do funny things, and so getting this ordering correct is significantly easier over on the PSP side. I think that's what I'm going to do. I'm going to pull in the PSP version because it does look like there's a bunch of ordering things that are happening here. That I'm not real thrilled about. And let me see what my... We have a script that was shared for getting a relatively minimal Splat config for for PSP functions. I'm doing this off screen because it's not tooling that we really have in the repo. Not because it's not valuable or super sensitive or secret or anything. It's just not, I think, production ready. All right, so I split those. I can flip over now. So I'm going to do what I normally do, which is looking for the PSP EU weapon functions. And so I'm looking for non-matchings. I'm going to get their size and sort by size, and then I'm going to try to match up size. So the PSP versions of these functions compared to the PlayStation 1 version are going to be anywhere from 20 to 50% larger. So a lot of the times we can get a rough estimate. So it's going to be one of the three biggest functions. And let's look at which ones we have in US. So it looks like the smaller of the two here. So a while ago, Biz Murphy gave me the advice to basically just copy and paste these in as assembly, and then what we're not gonna worry about the disassembly from the PSP side. We're just going to take our existing decomp from the PlayStation side and use that as the starting point. We're gonna have to clean up some variables here. Because those aren't necessarily defined in our context over here. So I need to fix the primitive structure has a additional 4 bytes right here after the next pointer. And so we need to make sure that's in place. And then we need to clean up some of these things that didn't port over. So it looks like we have some type issues. So between MetroWorks, which is PSP, and GCC, we're going to end up with some differences in what parts of, or what C they accept. Typically, anything that MetroWorks accepts will also be fine for GCC, but not necessarily the opposite. Oh, what did I do? So we are missing this definition, or declaration, I should say. This function name was changed since I generated the original Scratch. And so we need to find the game API struct, and I think this might be play sound effects volume pan, but let's look and see if we can figure out which one it is. Oops. Yeah. All right, so that has us compiling. As usual on the PSP version, we're going to be, when we do get something that compiles, it's going to look further or less close of a match than the PlayStation version. And that's okay. Usually it's relatively straightforward to fix, and we just have to go through and start doing that. So the first thing that we have here is, and it's interesting to see how code changes between an optimized version and a non-optimized version. So the MetroWorks version of these overlays are not optimized. The GCC version is optimized. And so in this case, the optimized GCC version said, I can assign an immediate value here for this variable, but the non-optimized version is saying, no, you have to do an addition here instead, which is kind of funny. And likewise, this one down here is also an addition. And it looks like there may be, should be an equals. So we have stack pointer differences. There's nothing we can do about that at the moment. There might be. We can move some of these declarations around, but I'm not too worried about that. But if we would pull this back to the PlayStation version again, we can just copy the whole thing over. This will, so we're at 22402 when we apply this. We need to fix our context. After init stats and gear. So we're still at 22402. So we see, though, that an optimizing compiler will look at this and say, I know what the immediate value was, and I know what immediate value you're adding to. I can do that compilation, or I can do that addition at compile time, and just bake in the static value, the immediate value instead. All right, so continuing on, down around line 88, we're loading So in our in the original version, this 0 and this hex 80 are being stored in a register. But in our version at the moment, they're being stored on the stack. And so we get some additional instructions for loading those from the stack and then storing them back to the stack when we change the value. There's as we get rid of other variables and other things like that, those things will go away. There's nothing we can do about it at the moment. So here we have a for loop that looks like is being done in a slightly different way than written. This may be a mem set. Actually, let's do it like this. Let's see if that will give us the right thing. Nope. So our buffer was it is of size 16. Let's try built-in memset and see if that works. So if I remember correctly, we look at the destination, the number of items we want, and then the value. Is that and we're not getting the built-in version, unfortunately. No, I was wrong about the ordering. So we want, let me look up the man page. The great thing about all these old libc functions is you can't tell what the order of anything is. All right, so we're looking at destination, value, and then the count. Yeah, unfortunately, MetroWorks is not going to use a built-in version of that. So let's back that out and what's odd? I don't. I think I forked this originally. This construct is odd. Maybe I just need to fix the for loop. Yeah, that's what it was. I should have looked a little closer at how that for loop was written. Hey, Mozilla, good to have you back. Yep, working on back to weapon overlays. Last week we kind of took a week off from looking at weapons because the Maria clock room overlay was added, and I wanted to take a look at that. All right, so continuing on, 99. So again, this kind of points out a difference between the two versions. I liked having this ternary in here. It's nice and concise, but MetroWorks tells me that that is not acceptable. And we're actually not setting this as a separate variable. We're setting this in line. in each of these conditions. And do I have the order right? I don't have the order quite. Oh, actually, these are... No, I have the order backwards. And so the question was, do I prefer equal 0? The PSP compiler prefers equal 0 here, or does not equal 0. So I'm going to go with what the compiler says. Yes, so the boss Maria overlay, mar.bin in the boss directory. So that is code complete decompiled. There still is data for that overlay that still needs to be decompiled. All right. So in this case, we're using the right offset into weapon, but we're storing a word instead of storing a 16-bit value. And so let's look at the definition here. So we want our extension, which is ET weapon. So this is being used as a, or it's defined as a 16-bit value, or sorry, 32-bit value. But our function wants it to be a 16-bit value. So that could be that really this should be a 16-bit value, and we need to update this structure and make sure that our padding is correct. Or it could be that the structure for this particular weapon is slightly different than other weapons. So let's look and see what other weapons are using offset 90, and there's quite a few of them, so I can't just change the value here. Actually, many of them, though, look like they have, in every case where it's being used, it's not just using the weapon overlay. Let's see if it is actually ever being used as, sorry, not weapon overlay, the weapon extension. There's one place in weapon 27 where it's being used. So let's look at how this field is defined in these other ones. So we want to look at shield, this med shield laser, and karma coin. I'll look up karma coin first. So karma coin has it as a 16-bit. Shield has it as a 16-bit. Med shield laser. In med shield laser, this is a pointer to a target. So that one is completely different. Let's see where else this is being used. Sword and weapon 46. What I want to find is are all the places that are using this as a numeric value, are they all using it as a 16-bit value? I forgot the other one that I just said, weapon 44, weapon 46. Because if they're all using it as a 16-bit value, or that's the most common use of it, it probably makes sense to change the type to 16-bit. And there's going to be the one area that, yeah, 16-bit here as well. So my guess is that that offset 90 field should be defined as a 16-bit value, and we probably need to change then entity the ET weapon extension to be 16 and deal with the fallout of that one this med shield laser parent setting that field here. Actually, we don't even have to do that. This weapon 27 here. I'm going to make an assumption. And you all know what assumptions do. So offset 90 here was the target. And so we're going to go to the parent. We can look at the MedShield laser extension here too. Oops. And this is setting this pointer to null. Yeah, so roaming, that's what I'm trying to figure out. Is there any code that's using this unknown 90 field as a 32-bit value? The only thing that I can find is this one line here. Everywhere else, it's using the union to go into a struct of a different shape. And in every case, when I found this field in those other structs, it was always a 16-bit value. That could be wrong. I could be totally missing the mark, but I don't think I am. So I'm going to redefine that here. When I pull this code in eventually, I'll have to fix it there. I might do this as a separate PR because it does look like a fairly simple change to make. But fixing that fixes our instruction. Then we're loading the 16-bit value. And it fixes it down here as well. It's possible, I'd have to look at these other cases too, but in weapon 12, where we're using the sword extension, the S word, how often are these fields that are already defined in the regular weapon extension, and I could just use those instead. So I'm going to go through this list here and see if those are sensible. So A0 would be acceleration Y, 9A unknown, 8A unknown, 9-8 unknown, 8-8. This is a palette, and the negative value implies that it's a palette from the overlay. My guess is that 9-8 is also a palette of some sort. 9-6. 9-6 we don't have defined, and this might be a similar scenario where it's a 32-bit value here, and we need to split it up into two 16-bit values, so we'd have to look there as well. 9-4, again, same thing. If we treat that as a 16-bit, that would fall into place. And then the unknown 90 there. Let's see if there's other... A0, probably acceleration Y. I'd have to look a little more deeply into these other ones because there's quite a few. But if those can be split up into 16-bit values and we can get rid of some of these additional extension structures, that would be really nice. So I'll look into that later as I'm doing this. It fixes our problem though here. So we have a few items here. So we have some register moves that aren't happening. That's not something that's controlled directly, so I'm not concerned about that at the moment. I'm hoping that will fall out later. And now we're back to this this gob of assignments, and we can see using these offsets whether we have this ordering correct or not. If the ordering is correct, then on the PlayStation side, there's probably something else going on that's causing the reordering. So here I'm looking for offsets. Offsets are always written in this form. Last week I wasn't sure. I couldn't remember the difference between Intel and AT&T syntax and which one's the terrible one. This is AT&T syntax and it is terrible. And so one of the things that we have for how offsets are written is we have some base. In this case, it's this register, and then the offset into that register, and that's how structs are accessed, or how it's written for struct access, because the assembly doesn't know anything about field names. So we're looking at offset 1C here, and so I just want to see, are the offsets into those where those registers are pointing, are those the same? And as long as they are, then I'm not too concerned. The first one we see different is here. It's a different instruction, an and versus a load word on line 117. And so something needs to be done about that. And so that's taking register S8. And it looks like it's actively masking it to a 1-byte value. Here I talked about it a little bit ago, but we're loading a value off the stack versus using that value from the register. There's nothing that can be done immediately with that, so I'm not too worried about that as well. So we're doing the same thing here as well. Just masking that. And in this case, though, it's adding and not doing the OR. So now there's going to be quite a few of these. I'm actually not sure why. Oh, it looks like this value is being loaded into a register. And then being assigned. So V1 is coming from, oh, it is this immediate value here. So it's being stored in a separate variable. And so when a value is being stored basically to all of the channels of a color, I usually call that brightness. It seems like it may be an int or a short, because having to be masked every time. And it would be unsigned. Let's get back to this. And so basically all of these need to become assignment against brightness. And so I want to see, unfortunately, this is being stored off on the stack as well and not in a register. And because it's being stored on the stack, we're going to get a load word associated with each of these, which will add a bunch of additional instructions, which is not what we want. But as some of these other variables go away, we should be able to get that back into a register. I'm going to copy this over and see if this is any better. So we're at 22402. Yeah, 22322. So 80 edits closer. Do we do 80 edits in the last half an hour or so? I don't know. Did I get Twitch affiliate? Yeah, I signed up for Twitch affiliate. So I don't expect anybody to subscribe or do any of the Twitch things. Mostly just playing around with it. I do appreciate follows. That's great. And if you're a Prime member not doing anything with your sub, I don't mind taking it, but you know, do whatever Twitch things you want. There are some things around bits and other things like that that I have to look at. All right, so I think that's where we're going to leave this one today, and we'll come back to it tomorrow and try to finish off. I don't see anything so far that's overly complicated in this. I just haven't looked at it very closely yet. But if we could get weapons done this week, that would be awesome. Most of this looks pretty straightforward. It looks like wherever this was forked from, let's see where this was forked from. Oh, Josh has Josh is pretty close, 83%. This was forked from an anon a couple weeks ago. So there might be something funny in here. Sometimes I'll do this as well. Copy these bytes over from the data segment just to get a sense of what shape that is. There might be something going on there that we need to look at. We can look at Josh's as well. But I think that's all I'm going to do today on the stream. It's only weapon 30. Weapon 30 is the only one. That's the last weapon. There's 2 functions remaining in weapon 30. My counter is functions remaining, not weapons remaining. All right, so if you want to know more about Castlevania Symphony of the Night decompilation, go to soten.z.dev. You'll find a link to the GitHub repo and a link to the Discord server. And a lot of action, a lot of people coming in and contributing. Really excited. Happy to see people coming in from the stream and from YouTube and participating. If there's anything that people want covered, feel free to chat. I'm Sulako in Discord, so feel free to reach out to me or anybody else, and we're happy to help. We'll be back tomorrow, probably looking at weapons. I have some what should I say without doxing myself on stream. I have other commitments later in the week, so I'll be streaming tomorrow, but then off until the next week. And so I won't be around for a while, but I will come back in a week from Wednesday. I'll be back tomorrow, and then a week from Wednesday, I'll be back again. Adios. Thanks for joining.